Hi guys, so continuing our DSA course, and you know what the topic is if you have seen the last video, but if not, then let's try to guess with this problem what can be the topic, right? Maximum path sum in a matrix. Okay, given a matrix, so let's take it to the docs. If not, take it here then. So you are given an encroching matrix of positive integers. Okay, there are only three possible moves from a particular cell of a matrix. If you are at r comma c, then you can jump to r plus 1 comma c. Like row is going to change, as you can see. R going to r plus 1, you can go to c plus 1, c minus 1. Starting from any column in row 0, return the largest sum. Row 0, right? Any column in row 0 and the largest sum of any path up to row n minus 1, which is the last row. So you can follow any path like this, and the largest sum of that path you have to return. Note, we can start from any column and can end at any column, right? This is a very important thing, in a way that, yeah. So how will you, so just to make sure that we are on the same page, let's say if this is the thing, um, input, what do you think will be the answer? The answer will be to take 348 and 618. Summation of them is comes out to be 1009. Okay, so 391 and the 618. Okay, the summation is 109. So how you do this? So yeah, this is the problem. Okay, so clarification before. So my matrix contains integers range like the sum. What is the range of integers in the matrix? Why? Because like then sum should I consider as long or what? So that's fine. Largest sum of any of the path. Okay. Okay. Can I assume all inputs to be valid? What does that mean? That if this is positive integers, so my matrix will always have positive integers, and I don't think there are any clarification question in this. Can you ask about it? You can ask about the range of this n, how much bigger it is. Oh, okay, so one way to do this can be if I start from any position of row 0, then I would like to start from the position which has the maximum value, and then based on that I can see I have three options down from there who has maximum value. I will go there and then it has three options, right, or maybe two, right? So based on that I'll take, but there is an, I think this would not work as I've only considering like maximum in the first row. So in this example, it is fine if I consider 391. But let's say if there was something else like 11 and 12. So 391 if I take, now I cannot take 618 in the second go. I can only take something like 12 or 193 because these are the two options that I have with 391. So it's better to go with 348 and 618, right? Yeah, so for that, I cannot always say that choose maximum. So one way to do this can be if I take all possibilities from row 0, and if I've taken something like cell I comma c, I comma j, then there are three possibilities coming from this, which is I plus 1 comma j, j minus 1, j plus 1. So then I will call on that key, calculate the answer for this particular part key. If you're starting about I plus 1 comma j minus 1, and then you have three options in down from you. So what will be the total answer from that I can take, and then based on that I can decide the which step should I take, because what I would not just see only one value and take the step, but rather I would like to have my complete answer like, okay, what is the total answer from I plus 1 comma j minus 1, what is the maximum value that you can get till you reach the last row. So based on that I will compare not only the single value. Okay, so for that, yeah, so what will be the time complexity? Yeah, so for first row I have like n options, and then I get and then every let's say when I choose yeah, the time basically, and then I can also, before he asks you what will be the time complexity, yeah, so the time complexity will be exponential because every possible option has three choices, and then similarly that will have three choices. And but I think we can reduce the time complexity by using a dynamic programming, and something storing something as state as a dp of I comma j as the yeah, the answer for the maximum value which you can get if you start at I comma j till you go to last row, that I can store, and the state would be just which row I am, which column I am, so the current cell will have a unique value. So I can say for I just need to compute the answer for these, so I will be calculating the answer for a particular cell just one time. So in that way it would be order of n square time complexity, or basically n into m. Yeah, okay, yeah, so let's code it. That would be good. Okay, so yeah, I think this is a really straightforward problem. So now I'm shopping, and what we will do. So this is again like now if I tell you, it's a very common problem, but that's how you have to approach it. Um, in the real scenario, that you have to say, okay, I should take 3Ds. First you say that I should try to select maximum, but no, that will not work in this case. So give him example that it will not work, and then see key, okay, now the possibility we have, like one way of doing this is to take all the possibility. Okay, so that will take, so for this I will have of the three options, then for this I will calculate answer for all of them, and then so I can do recursion. Okay, so what will time complexity? And time complexity exponential, because it will have like every option for choice has three, but we can store this as like I comma j. So then the basically we'll be calculating the answer for each cell one time. So there are n into m cells. So this will be the time complexity. That's up. And now you can start the as time complexity is discussed. The next thing is code. Then that is obviously always the case, or then they will ask something follow up, or just add something, tweak something. Right, so in our case, if I have to write the code just to show you guys what we'll be doing, so we will be just having all the columns 0 to m, and then my r will be equal to maximum of r comma solution of basically row is fixed, column is now I have chosen as this I, and I have to go for all columns. Initially r equal to 0, and whatever you will get as maximum, see out r. Okay, and based on that, what a solution of I comma j means is that yeah, you have three options, right? O1, O2, O3, and based on that, like whether you have an option or not. So initially you can just have O1, O2, O3 as 0 0 0, and then you don't know, because like only if the this is valid, right? I minus j minus 1 is valid, I comma j minus 1 is, sorry, I not I plus 1 comma j minus 1 is valid, or you can also say if it is that is not valid, you just run this. Yeah, one thing can be key o1 is equal to because yeah, you can run this solve of I plus 1 go to I plus 1 and j minus 1, and so on so on so on. But if you reach I is equal to n minus 1, you return, let's say whatever 1 uh, 1 by 1 like yeah, value which you are at, and you want to maximize this. So if it is not valid, if I goes, let's say, less than 0, or j goes less than 0, or I goes greater than n minus 1, j goes out of bound like m. I don't think I pay there should be any constraint, because I goes in very linear way, 0 to n minus 1, right? It goes in linear way. J है जो which can create a problem. So just focus on if this happens or that happens, return -1 E9, because yeah, then because I have to return max of that. So यहाँ पे मैं directly I will be writing max of these two options, right? Solve I+1, I-1, comma j, and so on. So that would be doing. Let's move to the next one. Minimum number of jumps. Starting the first index, you have to reach the last index. How many jumps will you require? And the jump is so okay. Take it there. Discuss the approach first. Time complexity. Ask clarification question first. Then start with the observations. Then go to the maths with solution. So on, so on, so on. Why? Okay, so you are given an array of size each element array ARR, where each element represents the maximum length of jump that can be made forward from that element. This means if the array of I is equal to x, then we can jump at distance y, so that y is less than or equal to x. Find the minimum number of jumps you reach to end starting from the first element. If the element is 0, then you cannot move through the element. Element is 0 means like you cannot make a jump of length 1 even, or even 1, not even 2. Okay, so where each element represents maximum length of a jump, this can be made forward to that element, which means if I is equal to x, then you can jump distance of y such that y is greater than x jumps to reach the end of the array. Sure. Okay, so array is equal to x, then we can make jump of this starting from this element. If 0, you cannot make it, return minus 1, you cannot reach the end of the array. So you have to tell again, like find the amount of jumps which to end. So just to make sure that we are on the same page, if this is such your array, yeah, what will the minimum number of steps? So you will start from 1 and you'll go to something like 3, then you go to 8, and then you are all covered, right? You can also go to 9, I think, then also you are all covered. So you took 1, then you took 3, and then you took 9, and then you are all covered. So these three elements you took in your path. So that's your like minimum number of jumps that you did. One jump to 3, then second jump to 9, the third jump to go to end, right? So that's how your jump looks like. and these are values, not index, right? Are we now? Yeah, how do you do this? Okay, let me think. Okay, so we are starting from the first index, and then we can choose any of the value which has the index lesser than my current range. Then I choose that value, and then I need to see, okay, after this is the range which I have. Which candidate gives me the next range? Okay, so that's what we can do. So, okay, so for degree of n, the range is 0. Max range, and as soon as my max range goes after like endpoint, then I stop and return 0. So basically, yeah, basically, yeah, that I will choose, right? So this is my range, and this is the maximum element, not maximum element, but this index plus its value, which is the maximum in this range. So that as soon as I reach my endpoint, I will, yeah, take that as the next thing. And I've already seen the values for this one, and what's the maximum? So I need to see the maximum value for this one. So yeah, that's how I think we can do. I think we can do it like so. One way of doing this can be if I start from one and then I update my max range to one. Like you can go to first index without any issue, and then in between my way of reaching that maximum index, I will keep on updating my next possible step. So next possible step would be like, yeah, in this case it is just one. So whenever I see 3, I see my next possible step can be index plus value, which is 3. You can go to the fourth index 0, 1, 2, 3, 4, which is 9, right? So that is updated as maximum, and yeah, and when you are on 5, you see that your current maximum is already on 9, so this is valid. And then you will take what 5 gives me like index is 2 plus 5, and it is something, let's say 7, and that is, yeah, so I update it with this. Then I see 8, then I update this 4, this with 4, 3 plus 8. Okay, this is the index where I can jump, where yeah, to where I jump, and then I see also see 9, and that is how I update that. 4 plus 9, that gives me something like index value, and yeah, that is fine. Max becomes this. So also as soon as max becomes that greater than this, I think you should return 0. Okay, and then you return like whenever you actually take a jump, then you do plus 1. Okay, like what do you mean by actually take a jump? Because at first step I have only one option, so I took the jump, so that's why I did plus 1. And then at 3 I had like 3 options, so then I took yeah, I had 3 options, but I had 3 options, and this gives me greater than this. So this returned me somehow like, no, I just updated my maximum, man. Okay, you can ask if you want to write thoda sa pseudocode na. Okay, can I write a small pseudocode for a better understanding, thoda sa, for a bit of understanding? Because I think that would help me to understand it more clearly. Okay, go ahead. This was one thing which you did not ask, or you can ask if you wanted for pseudo. So can I write a bit of a pseudocode? I think that would help me to understand it clearly. Okay, so currently these are the, if that situation comes that I is greater than your max, then you return -1. Like, yeah, no answer possible from there. And these are my minimum steps that I take. Okay. Okay, and I update my maximum every time by I plus AI, and um, initially our max was 0. There's a maximum where you can go. And quickly it updates to 3. When it updates to 3, see that okay, it's fine then. I think I can make a current window. You see current equal to max of max. Current becomes max, and you see st plus plus. So 0, we have an option like to go to this, and that's how we set this I is equal to current st plus plus. You take the step and current equal to max. Now you're on this. Fine. Again, yeah, max is something. Okay, and you're on this now. I plus, yeah, saying that okay, I can go to this. Fine. And I can go till this point, right? Okay, take a jump to here to jump to here. Now, as soon as you can take a jump to this point, just do a maximum of plus AI. Okay, so this, and then 5 and it's not equal to max, and I plus AI plus this is the must by I comma CR you took ST plus plus CR is equal to max कर दिया ठीक है. Okay, you can also say if current return 1 क्योंकि एक की जंप ले लो. Yeah, ST or ST plus 1 as soon as my current becomes that. So let's try to think if my ST is 0 initially, then because like, I don't know whether I should do ST or ST plus 1. So that's why sometimes pseudocode is helpful. Pseudocode is helpful in many of the ways. So you should write it and ask if you can write it too, if it gives you better clarity. So initially I'm on 0, ST0. So yeah, I take one step straight away and my max is equal to 3. Sorry, I plus AI, which is 0 plus 1. Yeah, now you're on first index. I is not greater than max but equal to again. So max equal to becomes 1 plus 3, which is 4. Okay. I is equal to CR. Yes, it is. So you have to take a step. Okay. So let's press current equal to max. Okay. So you have taken a step. Step value is equal to 2 now. So fine. Basically, from 1 you take off, from 3 also you take off. Have to take off, right? Go to sum of the 5, 8, 9. Then you see 5. Okay. CR is not. I is not given mx because I is 4 and sorry, mx is 4, I is 2. So you can take this and mx becomes something, then mx becomes something, and mx becomes something again. If I is here does not matched, so currently you have taken 2 steps and now your CR becomes greater than n, you return ST plus 1, which is 3 steps. I think yeah, you have to do ST plus 1, right? Because before that you have taken 2 steps, ST number of steps, and your current is greater than n, but you have not taken that step. As soon as it becomes greater than n, I'm not like yeah, is it greater than or equal to n? I think it should be equal to n, and then I take the step, right? Yeah, I think that should work. N complexity is linear, order of n. Uh, Step current equal to 0, mx equal to 0. For end I is equal to 0, I is less than n, I plus plus. If max current becomes greater than n plus 1, or like mx becomes greater than or equal to n also, you return st plus 1. The only case you return minus 1 if your uh, mx is lesser than I think. Yeah, mx is equal to maximum. Two things, take step first and yeah man, cr is equal to next mx. I think everything gets handled here, even if it is minus 1 or valid or not. Once you are on 2, then you take this and this. You have to take a step, right? Acha. These are the possibilities where you can go. Acha. So current becomes equal to IPCI, which is 2. So sorry. Max becomes equal to that. आप 3 को देखोगे and you will see that okay, there's something max. 1 को देखोगे, there's something max about it. This 4 don't you take you to like n, but it takes you to 1, 2, 3, 4, right? Takes you to n minus 1. Done. Is c plus 1. Okay, like तुम first step पे ही पहुंच सकते हो. Yeah, man. So if mx less than I, return minus 1. That is like most important thing. If you can't, this means that you can't be on this index. If you can be on this index, then there is a possibility that this is the last thing and you just jump to that, take this index and jump to somewhere which takes you n minus 1, and elsewhere you have to do max, and then you have to do if I become cr, then you do st plus current max. Guys, that's about it. Okay, bye.